Welcome to the Touchstone Energy Home program. Building a new home takes time, planning, and information. You want to do things right, and there are many decisions to make. But sometimes there's not enough time to fully consider all of your options. That's why we've developed the Touchstone Energy Home program. There are many ways to include energy efficiency details in your home's construction that save money and provide years of comfort. Whether you're a builder, a contractor, a homeowner, or a member of a Touchstone Energy cooperative, these guidelines can help you build a house that uses your energy dollars wisely. Your local Touchstone Energy cooperative reminds you to think about energy efficiency when planning your new home. Touchstone Energy is an alliance of more than 600 consumer-owned cooperatives in 45 states that collectively deliver power and energy solutions to more than 22 million customers every day. We are committed to providing superior service at affordable rates to all customers, large and small. So let's take a look at some of the features of a Touchstone Energy home. This is a construction site of a Touchstone Energy home being constructed by Iowa Central Community College's carpentry class. Their instructor is Bill McAnally. Hi, Bill.
Hi, Mike.
Good to see you today.
Good to see you.
Say, it looks like you've done a lot of things already. You've got the foundation established and walls poured. What have you had to do in order to make this a Touchstone Energy efficient home?
Well, one of the first things that we have to control is moisture, and to control moisture we bring a lot of rock, and we put 2 to 8 inches of rock underneath the floor, 6 to 8 inches of rock underneath the foundation and the footing area, and we also bring it up around the outside to keep moisture from getting up to the side of the house.
Okay.
You can see on the foundation wall that we have a peel and stick style of waterproofing. You can use a spray on or roll on, but we chose to use this particular product in this house. We have to be able to control that moisture because there's so much that's going to be exposed on the exterior. So we've put 2 inches of extruded polystyrene on the inside, and underneath the basement floor we have 1 inch of extruded polystyrene to insulate that basement floor to keep it warm so we don't have any mold issues down the road. We also have a vapor barrier underneath that slab to keep radon gases and moisture from coming up, and that also keeps the house a lot drier, a lot easier to control.
But what have you had to do in order to make this ready to be a Touchstone Energy efficient home?
Okay, let's walk down and take a look at it.
All right, sounds good.
Well, this is a peel and stick waterproofing that we've applied to the outside of the foundation. The foundation wall is actually 8 feet tall, and we've already done some backfilling with some clean limestone chips. Below the foundation wall we have a concrete footing, and then there's gravel underneath that concrete footing that also helps the groundwater to get over to the sump pit. Our goal is to keep the insulation dry and to keep the basement floor dry. Right below the foundation wall, if you go straight down, right as it hits the top of the footing, there's a capillary break that prevents any moisture from coming up the wall and then possibly attacking the wood through moisture.
Now, the insulation this time is not on the outside. Is it preferable one way or the other?
In this particular application, we had to use the insulation on the inside because there's so much of the foundation above the grade.
Can we go ahead and take a look at what you've done on the inside?
Sure, let's take a look.
All right.
This is the 2-inch extruded polystyrene that's been applied to the interior of the basement. It goes all the way down to the top of the footing, so it also insulates where the actual floor meets the wall. We've got the capillary break underneath this, and then this carries right up to the top of the wall, and then where it meets the band joist, that's an area we've already insulated on the outside with foam, so we can always add more insulation up in there. Plus, we can always add more insulation to this. We'll eventually mechanically fasten this with some wood furring strips to be able to attach your drywall. If you can keep your floor surface warm and you carpet it like a lot of basements are, then you won't have any mold underneath the carpet. There's always that issue with that if the carpet sits on top of an uninsulated floor that you could have mold growth. Okay. We have a vapor barrier underneath the floor to stop any moisture vapor and any radon gas from coming in. So then that all gets trapped over to this sump pit. This particular type is called a jackal pit, and we can pull all of the radon gas out of this and exhaust it if there is any radon issues in this particular house.
Excellent, excellent. Well, it looks like there's some things going on upstairs. Should we go ahead and take a look at that as well?
Sure.
All right. When I saw this going up and saw your students working on it, I thought perhaps they'd done the corners wrong at first.
Right, right. A lot of people think that. They think that the more wood, the better. And in the corners, that's the absolute wrong way to think. What we're trying to do in a corner, because there's lack of air movement that's in a corner, is we want to keep these very, very warm, and so we've got to eliminate a lot of the wood. There's no structural value to having all this extra wood except to hold this piece of drywall.
Okay, so this is recessed then, so you can put more insulation here?
Right, this is what's called a two-stud corner. It's been around since the 40s, but for some reason it's taken a long time to take off. What we do then for drywall is we either apply a corner bead, drywall corner bead, which is a 90-degree angle, or we use scraps of, say, floor sheeting. We'll attach those to the back of this stud, and that way the drywall can come over. And then there's only one stud drying, and when there's only one stud drying, we just don't have any callbacks for drywall cracks anymore.
Okay.
While we're building these, a lot of people will say, well, where's your plywood sheeting?
Yeah, they're used to seeing that.
Sure, they are, and we don't want any of that product on the walls. If it's a high wind area, maybe so, but we'll still put foam on the outside.
Okay.
And the reason we do that is this foam then acts as a thermal break. And so that way the cold air or the cold temperatures can't travel through the sheeting, through the stud. And then, you hear these stories or see on TV where you'll see shadowing or ghosting is what they call it.
Right.
That's because the stud is so cold that the moisture inside the house condenses and the dirt in the air hits that, and you see all these dirt spots.
That's what causes that.
That's what it is, yeah.
Okay.
And they always blame it on candles. Well, the candles just produce the soot that sticks there.
Sure, okay.
Hey, Mike, how you doing?
I'm doing good.
Good
Good to see you again.
to see you.
Man, since we were here at this construction site, all kinds of things have been happening.
We've done a lot of interior walls where they attach to the exterior. We've looked at ways to control our moisture vapor in the building. We're thinking about how we're going to insulate here in probably a couple more weeks, and hopefully in the next couple days we'll have this part of the house shingled.
Well, as I just came in, you were working with one of these.
Right,
I'm wondering, what is this?
Okay, well, this is a vent chute. There's a lot of different styles, but this is the one that sells the most around here. What we have to do is we have to, by code, get some attic ventilation from the soffit, the overhang, all the way to the peak. And when we have a vaulted ceiling like this, sometimes it's a little tough.
Okay.
So what we have to do is we have to put a vent chute up between the rafters. We go every other bay, not in every bay, but every other bay, and then so that the bottom edge sticks out past the exterior of the wall. And then this will go all the way up to, about where there's 2 feet of insulation in the attic, and then it'll stop. So we have to have ventilation go all the way through.
Now, what's the advantage to the homeowner? I mean, why would they even care that you're doing this?
Well, you have to because of the building code, but it's supposed to be able to keep your attic a little bit cooler in the summer, and you don't have any damage with your shingles, from overheating.
Are there any other Touchstone energy efficient features here?
Yeah, the thing about this is, we've got these trusses that have a 9-inch raised heel. You can see on the truss that, the sheeting, the roof sheeting is 9 inches away from the top of the wall.
Yeah.
We've got to have enough insulation there to keep that whole area warm.
Okay.
And so what we've done is we've ordered an energy truss or a raised heel truss. It comes up 9 inches. And then what we'll do is we'll have insulation go all the way to the top of the wall, and we'll take like scraps of foam or OSB. And what these will do is they'll slip in underneath the vent chute, nailed to the outside plate, and then that keeps the insulation from falling into the overhang.
Yeah, that's good, right?
The last thing you want to do is take fiberglass and just roll it up in there, because it'll eventually fall out. So that keeps it warm in that part of the structure where there's very little air movement in a house. So it'll keep that part of the house warm.
Excellent, excellent. Well, sounds like a great plan there. Let's look at the next feature, okay?
Okay. This isn't your standard corner. Right here is one of the biggest energy losers in a standard home. Is they'll have all these studs stacked in here. This is the way we all learned how to build, is either put 3 studs and then 4. You got all this lumber, no insulation. And half the time when you did put it together, you'd throw some fiberglass in on a day like today, and it's not raining, but sooner or later it's going to, and it would get wet. Or the worst case is when the electrician's drilling through there and he wraps all the insulation up on his bit. So we've eliminated all that, and you really don't need to hold that much. All you're doing is holding this stud in place.
Right.
It's held at the bottom, it's held at the top already on the plates. All you need to do is keep it from wobbling and just take some scraps of 22.5 inch, in this case, 2x6, 2x4s,
yeah,
and just nail it right here.
You wrapped it in plastic though, why?
Right, well, there's going to be a consistent vapor barrier, or vapor retarder in the house, and if we were to not wrap the stud as we put it up, we'd be coming along over to here and stop, and then have to try to cobble it up and go around. So you just wrap the studs.
Nice and simple now.
Nice and simple, right.
Well, we're getting ready to put some sheetrock up here, so now how are we going to hang the sheetrock?
Okay, well, everybody asks that question, especially on a unit like this, is we stick this corner bead in. All this is drywall corner bead, just standard. You can buy it at any lumber yard. And what you do is you nail it onto the stud about every foot.
Right.
And then this piece of sheetrock comes in first, and then this one comes over and pins it in. And then you attach the sheetrock to this stud. Now, the big advantage to this, even if you weren't thinking of energy, is there's only one piece of wood drying.
Less cost?
Less cost. You don't have all this wood here. And if there's one piece of wood drying, you don't have the drywall cracks.
So this is why Touchstone Energy Efficient homes have corners like this.
Right. This is how the interior
no cracking,
partitions.
Less wood cost.
Right.
And bottom line in terms of efficiency.
You've got all this consistent ventilation behind, and from the outside, if you take an infrared test, you can't even tell where your inside walls are at.
Excellent, excellent. Now you said Touchstone Energy homes have something special with regard to attic space. Let's go ahead and take a look and see what that means, okay?
Okay.
All right. Well, Bill, we're standing here really in a vaulted ceiling, and this looks like the attic to the house.
Right.
Again, what's going to make this a Touchstone Energy home?
Okay, well, as you can see, this is the attic, and normally you wouldn't be able to see this at this height since we're up in this above the hallway. But we're going to eventually blow about 2 feet of cellulose up in this attic. We blow at 2 feet, which seems like a lot. But, you know, when it's blown, it has a lot of air in it. So what it'll do is it'll settle. So we want to make sure that we have a good amount of insulation in this attic.
Is that a Touchstone Energy standard?
That's the Touchstone Energy standard. Well, you know, it depends on what part of Touchstone Energy you're actually in, as the R values do change. You know, here in, say, in the Fort Dodge area, we have a standard, and southern part of Iowa is different, northern part. It just depends.
So it's climatically changing, and
Right. A Touchstone can give you all of those, you know, R values that you need for your specific area. The neat thing about this particular part of the house, though, is we see a lot of problems in houses when you have this transition from a vault to this this wall section
right here.
And a lot of people can say, yeah, I know what you're talking about, because I'll see a crack along here and there. And what happens is, okay, we go ahead and fill this with insulation, and then we fill this up here with insulation.
Right.
So we've got 2 feet up here, and then that comes over to here. Well, what about this little magic triangle?
Okay.
Right there.
That's where the problem's going to be?
That's where the problem's at. You can go into quite a few houses, be in the attic, look, and you'll see bare drywall.
Yeah.
So what you want to do is you want to be able to take and treat this exactly like an exterior wall. Put this 2x6, we'll frame these all the way up, and then we'll put foam on the back side and treat it just like an exterior wall. So we'll have our 1-inch foam in the exterior. We'll put our 6 inches of insulation in here, our vapor retarder, our drywall, and then we're not going to have a problem with any kind of moisture or ghosting or any thermal problems here. It just takes care of everything.
This looks like Christmas wrapping to me.
Right, it's pretty, isn't it? It's wrapped nice and tight. This is a Tyvek house wrap. The same thing as home wrap. It's the exact same thing. They've just changed the names in the last few years. Some people get kind of confused on the terminology. What this does is that it keeps moisture vapor to be able to, if it's trapped inside the wall, it can travel back and forth. But also it stops air, okay? Because an air molecule is larger than a water vapor. And so the vapor can travel back and forth, so it's not trapped inside the wall and, again, getting your insulation wet. This is a perfect drainage plane, because our problem with the houses that we have today is no matter whether it's vinyl, wood, cedar, brick, doesn't matter. Water gets through it, and it has to be able to get behind the siding and travel away. So you don't want it in the wall. It hits this and goes right down.
Now, where are we standing in relationship to the house? I mean, this is looks like it's been framed out in some way.
Right. Well, what we've got right here is the garage area, and we've put in all this rock for drainage and support. We're going to have 2 inches of foam on top of that, but we're also doing a frost-free foundation system. And the key to a frost-free foundation is we don't have to do near as much excavation. We can go down 18 inches, 24 inches, and then we go out horizontally with 4 inches, or 2 inches thick foam, go out 4 feet. And that way the frost can't get all the way back. The frost doesn't know which way it's going. You know, we go 4 feet in the ground, so if we go out, you know, and it's nothing new. It just became code just a couple years ago, but the Europeans and Canadians have been using them for decades, and finally the physics caught up in the United States, and it's finally being allowed, and it's a beautiful way to do a foundation.
Well, you were saying earlier, though, that things have changed a little bit in terms of even how you cut the tie-back.
Right. You know, 10, 15 years ago, the proper way to install a window was to go ahead and just cut a big X.
Right.
And then you would fold the edges around, and you'd install a window. Well, on the outside of the windows, you have a nailing flange. And that nailing flange, for some reason, we started thinking that was actually a flashing to keep water out.
But it didn't.
It didn't.
Okay.
And so now the proper way is to go ahead and cut down the center and then fold the sides in.
Which we've done.
Right?
Yeah.
Cut it along the bottom and then cut it along the top. And then we've made these slips at the top to allow for flexible flashing after we install the window.
Okay.
Okay, so the first step, what we have to do is we have to put in a pan flashing.
Okay.
So go ahead and take that, hold it up about 6 inches on the side. We'll peel off the backing. Now the advantage of this flexible tape is on the corners.
Okay.
You don't have to cut it. Is just go ahead and start feeding your fingers right into the corner.
Like this?
Yep, just go right down like that.
Okay.
It bends. Now it's a little cold out today. Okay. Once it heats up, it really sticks. Okay. So all you have to do then is put a plastic cap nail right there in the corner.
All right.
And it holds it flush. Now the next step is to put the window in. Now the reason we put this here is so the window, when the window sits here, let's say the water does get in behind, like I said earlier, is it'll land on top of this and then go out the bottom. So we don't seal this bottom on the outside. After we get the window put in, we'll put expansive foam, minimal expanding foam around the window, but we just kind of spray a bead right along here to stop the air and leave this part open. So if there ever is any water, it can free drain. Okay, boys. There we go. Now, first of all, we want to make sure and get this level and plumb. And you'll notice that the framework of the window sticks past the framework of the wall.
Exactly. Right.
Okay, because there'll be sheetrock, there'll be drywall on this, and so then this will be flush with the outside face, and so you can just install your trim. Be sure and order your windows this way. It saves you a lot of time by having to put these extension jambs in later. And then on the window, you know, they do have the proper installation instructions, but they also have the NFRC rating on there. It's National Fenestration Rating Council. But what it does is it rates all of the windows. It tells exactly what kind of a window this is. This is a casement vent. That means it's operable. And it's low E, has a low E coating, a low emissivity coating on it. Argon filled, which is what we're really looking for, because there's 2 panes of glass.
Okay.
And you can just have air, or you can have an inert gas like argon, which is a better insulator. So all the newer windows have the argon on the inside. There's some other gases that they're trying to use, but argon's probably the most used right now.
And that meets Touchstone Energy
Right.
standard.
This whole window unit meets the Touchstone Energy Home program.
Okay, anything else we need to know in terms of making sure that we have an energy efficient install?
Well, you want to be able to get a double pane argon filled with a low E coating. The low E protects your carpet from ultraviolet. It reflects the heat back into the room. The neat thing about this particular window is it's not a triple glaze, and you know, everybody thinks we need to have 3 panes to be efficient. And the double pane window, when we've done infrared shots, it's amazing at how efficient these windows are.
Okay, so when you use an infrared gun, you can tell whether or not it's been efficient or not, and
you can.
And this does the job.
Right. This is a Touchstone Energy Home type window.
Excellent, excellent. Well, we're back outside now, and we're going to finish the install on this window.
Right.
Bill, what do we need to do?
We're going to go ahead and finish putting the flex wrap on the outside. This flexible flashing, and the key to this is to get it tied up against the window itself. And I know it's cold out here and you want to get inside, but you want to get this finished up. And we're going to leave one off of here. Remember we talked about how the water has to have a place to go?
Right, push out.
Yeah, we used to go ahead and throw another one across here, then you'd trap the water. So you're treating this just like a shingle. So the next step is we'd put the other side on.
Right.
And then we'd go ahead and put the top one on, overlapping the two sides. Right. Yeah. We would put that one on, just like this. And then this the paper would come right over the top, red tape it, and you're done.
Okay, excellent.
So that completely seals the water from the outside. So you've basically got all these belts and suspenders methods, but we've got to learn to put these windows in correctly. If we keep doing it the way we used to, we're just asking for failure.
This looks familiar to me, Bill.
Right, this is your generic fiberglass insulation, probably the most commonly used insulation in Iowa. Some of the other options are cellulose, which is recycled newspaper.
Right.
It's very sustainable. You could put that in. There's a dry pack where you'll put a plastic on the wall and push it into a certain amount of pressure, or they can put it in a kind of a damp, a sticky method, like a big old spitball that fills the cavity full.
Okay.
There's some foams that you can use. They're all real good installations, but it goes right back to this whole system. Everything has to be done correctly. For this fiberglass to work, it has to be completely fluffed up. It just can't be thrown in.
So a fellow might just push this in and say done.
It's just it's a waste of time.
Okay.
You can lose 50% of your effectiveness by compressing it. And you'll notice that there's
So how do you put it in?
Well, you just shove it all the way back in, make sure it's all the way to the top, all the way to the bottom, push it all the way in, and then pull the inside surface, bring it out flush with the stud. Maybe even bring it out just a little bit past.
Okay.
Now, you'll notice this doesn't have the paper, the craft face, somewhat called vapor barrier that's on there. Because what we do is, instead of using that paper as a vapor barrier, we go ahead and use certain feed came out with a new product called membrane.
Right.
It looks just like a plastic or a poly, but it's not. This particular product, what it does is once it's installed, it's sealed at the bottom, sealed at the top. We try to get absolutely all the air leakage out. And what happens if, let's say there's some moisture in this wall, let's say some moisture came in from outside somehow. If it's in there, the pores in this open up after about 12 hours. And so the moisture then will dry from the wet to the dry side, so it will dry to the inside of the house. So it's very, very, very forgiving.
Wow.
And so it stops the air, and it stops bulk moisture, but yet it can still let vapor back and forth, so you actually have a breathing wall, but yet you don't lose the energy.
Is this new to construction?
Yeah, it's fairly new. This was the European building code, and some of the new codes are saying you have to use a smart vapor retarder or a smart vapor barrier. And that's exactly what this is.
Okay.
It's forgiving. They say it thinks. But I don't know how it would. The other thing that we have to worry about though is whenever we have a receptacle on an exterior wall. So let's say that we have this insulation out. Before we even put the insulation in, what we'll do is we'll go ahead and put this box just on the exterior walls, wherever there's a switch or where there's a receptacle.
Why do we need this box though?
Okay, what we want to do is still keep the wall airtight. So if you just go ahead and nail a box in like this, you've got all these holes on the back where the air is going to breathe. You need to put your hand on here and you can tell if it's 20 below zero or if it's zero outside.
No, I've seen this put in before, but not this orange box.
Sure, you just put this in first, nail this in, make a slight cut in the top and bring your wire in. Then you fill this with insulation, and so you've got a completely airtight wall.
Okay.
And this, it's amazing, how much energy you add all these up, how much energy you're going to lose on those outside walls.
One of the questions people have is, how do you heat and cool a Touchstone Energy home? Well, to answer that question, we've traveled to Glidden, Iowa, and we're in the basement of Iowa's most energy-efficient home. In fact, it happens to be a Touchstone Energy home. Bill, when we get ready to look at a Touchstone Energy home, one of the signatures is the use of geothermal. And I'm asking, what are the considerations as a construction person we have to have in mind when we get ready to build a Touchstone Energy home with geothermal systems?
Okay, well, we've got to look from day one in our planning stages as where we're going to place the unit inside the house. How large of a mechanical room. Are we going to be supplying all of our heating and cooling needs with forced air through ductwork? Are we going to be using hot water radiant heat? There's a lot of things that we have to look at. That starts right from day one as far as when we start digging in foundation.
So begin with the end in mind. You have to at least have that thought through very carefully before you begin.
Right. You have to be working with your subcontractors in the very early stages so they understand what you're doing. The total design of the home goes into deciding how large the unit has to be. So they have to know how energy efficient the home structure, the thermal envelope, is going to be to correctly size the unit.
Okay.
And we're going to be getting some of our domestic hot water from that. We're looking at how are we going to actually get heat into the system, and it's brought in through loops that are in the ground. The loops right here, basically what you'll see from now on is you'll see just two come in.
Okay, so much simpler then.
Right, it's a lot simpler. There's not as many holes either through a wall or through a foundation. We're looking at radon. We're looking at a lot of different issues. So the fewer perforations you're going to have into the foundation or floor, the better.
So where does this go though in terms of the site?
Yeah, these just kind of run right out through the ground, and then these are connected. There's 4 wells in the ground that go down about 175 feet. So that's with vertical loops. We can also go with horizontal, and the horizontal is you just dig a large trench about 8 feet deep and maybe 300 and some feet long. So you need a larger area to go with that type.
So the size and the configuration of the building site is consideration as well.
It is. It is. If you don't have the space, you're going to have to go with vertical.
Okay.
And this all kind of ties in with as far as energy efficiency, but it also we have to look at our ventilation issues.
Okay. So typically in a home you'll see vent fans like in bathrooms and things like that. Or we can see the same thing in a Touchstone Energy home.
All you'll see is just the vent. Just the grill.
But no fan?
No, the fan itself is down in the basement. It's a heat recovery ventilation system. And what it does is it pulls outside air, runs it through a filter, brings it into your house. So you've got a constant source of fresh, filtered air. But we need to pull air from, say, the bathrooms, the laundry, kitchen, any place with a lot of pollutants or a lot of moisture. We want to get that out of the house. And so when that goes through the unit, the heat recovery ventilator, by its term, recovers the heat that's going out. So instead of
we're not just heating the outdoors.
Instead of just throwing and wasting all your energy, why heat the outdoors?
Right.
It pulls about 80% of that heat back.
Okay, so now what is a heat pump? And what does a heat pump do?
Well, we brought along Roger Hammond from Calhoun County RC.
Hi, Roger.
Hello, Mike.
Nice to see you today.
You too.
Can you help us with the heat pump?
Absolutely. Basically, as Bill talked about, a geothermal system is bringing radiant heat from the earth up and bringing it in to heat and cool your home. And when you think of geothermal, you think about something that is truly a system. And the way it basically works is you're bringing in the heating, the temperatures, the energy from the earth through this manifold system, and it converts it over here to what is basically a compressor. And what this compressor does is it brings in the heat that's from the earth, and it kind of compounds it and magnifies it, similar to what a refrigerator does.
Okay.
What it does is any of the excess heat that's produced by the system then can be spun off and sent over to the water heater over there. So it'll do a large majority of your domestic hot water on top of it. The nice thing about geothermal systems are some of the benefits is there's no combustibles because there's no gas involved with this. It's electrically
That sounds safer
operated.
to me. Is that true?
Absolutely safer by all means. Geothermal systems are very, very efficient, probably the most efficient system you can put in your home. 3.5 times more efficient than a conventional gas system for the most part. It takes a lot less energy to produce heat and cooling with one of these systems.
So that's the cost saving plus the safety that you mentioned in terms of combustibles adds up to a real positive experience for the homeowner then.
Absolutely. Safety combined with efficiency, that's what we're after in this day and age by all means. Due to limited space or other issues around your home, a geothermal heat pump may not be an option for your Touchstone Energy home. You may want to consider a second option, which is a highly energy efficient air source heat pump. And the way an energy efficient air source heat pump works is it actually transfers energy from the outdoors to heat your home in the winter and cool your home in the summer. You're always going to provide your family with safety and comfort. Whether you choose a geothermal heat pump or an air source heat pump, you can always be assured you're going to have a very efficient, cost-saving heating and cooling system for your home.
Well, that's the answer. That's how you heat and cool a Touchstone Energy home. We want to thank you for taking time to learn about Touchstone Energy homes. We know that you're excited about building your home, and now we hope you understand how you can incorporate Touchstone Energy standards into that home you're planning. It does take more time and attention to build a Touchstone Energy home, but you'll see that the comfort and the efficiency of this home will be well worth it in years to come.